All right, everybody. Welcome to What Are Normals? In this short series, I want to go through and just explain what normals are and how they work. You know, we're going to start at the very beginning, and we're going to work our way up to baking, right? So if we have a look here on the left, this is a high poly model. I think it's something like a million or two maybe 3 million polygons or something like that. You can see all the complexity and the detail, all these bricks. You know, we've got depth, things coming off surfaces. Really high res model. And then on the right, we have a model that's like, I don't know, 300 polygons or something like that. Very low res. But if we turn on our normal map, you can see now that we have faked the detail of the high poly on the low poly. And if we have a look, the obvious thing that's missing is the depth, the actual depth within the geometry. But for all intents and purposes, on the surface, it looks identical. So this is the isolated normal map. But if we actually bring in all of the colors and the roughness and everything, you can see that combined together, we can create a model that looks quite nice. You know, we've got roughness and metallic and all kinds of things happening. But you can see that if we actually turn off the normal map, you can just see how flat the surface is, you know. So normal maps add a tremendous amount of detail, faking the complexity of a surface when in fact they're incredibly simple. All right, so all of the concepts that we're going through in this series are software agnostic. They work in Unreal, Blender, Maya, C4D. It's all the same thing. For most of this series, I'll be using Houdini because it gives me the ability to explain these concepts at a very fine, granular level. So let's dive in. First thing I want to talk about is face normals. So if we have our, quad over here with our points. If I click on this button over here, we can actually see our face normals. And a face normal is essentially just that. It's a point that is perpendicular to a surface, and it gives us its direction, right? So if we have a look underneath here, this is the back side of the face, and this is the front side of the face, okay? If I then subdivide these, you can see now we have 4 quads, and each of those quads has a face direction, all right? If I click on this to reveal our normals or our point normals, you can actually see that these green lines appear, okay? Now what these are, these normals, is when 2 edges meet to create a point, then that point needs a direction, like which way am I facing? Okay, and generally they select the direction that the face that they make up is pointing. Okay, so you can see they're all pointing in this direction. Okay, so let's turn this off and move on. So if we see here, actually turn this on, you can see over here now, I've split this into 2 triangles. And over here you can see where these 2 edges meet, we have one line or one normal that's pointing out. But over here, there's 2. And this we'll get into in a minute, but it has almost everything to do with UV textures and UV layouts. For all intents and purposes, a point is made up of one or more vertices. So if I hit the S key to select and I go to point selection, you can see I can select this point and I can move it. Hooray, right? But if I go to the vertex selection, so we can select our vertex, and as we know, a vertex is the point when 2 lines intersect, you can see that I can't actually move these. If I hit the T key to move it, it won't allow me to move these vertices, right? And that's because, see, even here, if I do this, it's moving the point. It won't allow me to move the vertices. And that's because this point is made up of these vertices and you can't actually move them, right? That's just how it works, okay? If we move on to this example over here, you can see that we now have these 4 faces And on each corner over here, we have our 2 vertex normals because our point is made up of these 2 vertices that make up the polygons on either side. And in the middle, we have 4. So if I click this button over here, you can see that we have 4 vertices because this point is made up of these 4 vertices that make up the faces around it. Okay. Now, I'm just going to exit out of this. We can transform this point. So I'm just going to take this point over here and move it down. And you can actually see now that these vertices aren't pointing up anymore, or these normals aren't pointing up. See if I shift it, right? And what's actually happened is because these are all connected, right? Sorry, the vertices over here are all connected. When you actually change this, they kind of go, well, where do I point, right? I don't know what to do. And if you have a look at it, it just says, okay, I'm just going to take this face direction over here and this face direction over here that I made up of, and I'm just going to do the average of that and point in that direction. If we have a look at our this node where we give normals to vertices, you can see this cusp angle is 60. And if I move this down, when we get to this point, you can see it's splitting. And the reason why it's splitting is because this angle here is less than this angle here, okay? If this is greater than this, they combine, they average. And if it's not, they split, okay? And we're talking about this angle over here, okay? And this is where we first start seeing the idea of how normals affect the shading or how light interacts with the surface. So if we crank this up, you can see that this is nice. It looks round, even though it's not round. And if we bring it down, you can see it's split, okay? And generally when you read forums or talk to people and they start talking about hard and soft normals, when normals are split like this is creating a hard edge. And when they're not, it's creating a soft edge. So they're essentially just talking about split or averaged normals, okay? Now, if we then change this from, so I'll just put this back to normal. And what I'm actually now going to do is I'm actually going to split the points because everything that we've done has just been splitting the vertices underneath. But if I split the points, you can actually see now that the normals, even if we bring them together, right, because they're actually split, they're 2 points, they're actually just going to inherit their direction from the face that they're connected to. All right, hope that makes sense. So even if we change this cusp angle, it's not going to do anything because there is no cusp anymore because the points are actually split. Okay. So I want to now talk about point normals. All right, I'm going to turn this split off. And if we have it, look now, it says add normals to the vertices. So what we're doing now is we're adding normals to each of these vertices. But instead of adding them to the vertices, we can actually add them to the point, which is the blue thing. And if we go add to the point, you can see what happens here is, firstly, the cusp angle goes away. And we can't change that. And the reason is because these points, they get their direction from the vertices, right? They go, okay, I'm made up of, in the case of this, I'm made up of these 4 vertices. Which direction are they all pointing? I'm going to average those directions, and that's the direction that I'm going to point, okay? And you can see that even if when we split this, so you see we can change this nothing, but if we split this, you can see now, because these vertex normals are pointing up, that this point normals go, okay, I'm just going to find the average. Because these are pointing this way, the vertex normal, the point normal averages that, okay? Hope that makes sense. All right, so I'm going to turn, yeah, that's fine. And we're going to go to this example. And this is where we're going to talk about UVs, okay? So we see we have our face, it's got some UVs on it. So if I have a look like this, and you can see that if I split this face off down here, you can see how our texture moved. See like that? Because these edges are together, you you can see that there's no seam. It's perfect. But then if I split them off, you can see how the texture has moved, all right? And that's the reason why we have vertices, is because each of these face in our texture needs a coordinate system, right? So if I can't edit the UVs in the 3D viewport, so come on, I can't edit them here, but if I go into here, I can absolutely edit them. If I select that, hit T. Oh. There you go. And now I can absolutely move it. And when I move it, it's not moving the geometry, it's moving the UV island, okay? So that's why we have vertices and points. So that's why each one of these points here is made up of these vertices. So if I go into here and I select that vertice, I can move that. If I select that vertice there, I can move that. And if I select that vertice, I can move that, right? And you can see that's why they all have a normal, because these faces are like, which direction am I pointing? Okay, so in the next video, we're gonna have a look at point normals and explore how we can manipulate them to affect how light reacts with the surface. Okay, so here we have our quad again with some point normals. And what I'm gonna do is I'm just gonna rotate the back two normals. See, they're rotating down, okay? And you can see that it looks like we have wrecked the surface shading, but actually we've turned a flat surface into a quarter pipe. See, now if I bring this back up like that, you can see now it's like a flat surface. And then if I bring this down like that, you can see now it's almost like rounded, okay? So if I go to our next example over here, what's actually happening is we are interpolating between the normals pointing this way and the normals pointing up over the surface, right? So if I bring these points and I crank it all the way up here, you can actually see how this is interpolating like that from here to here. And by doing that, how light reacts with the surface is, you know, as it hits here, it's like pointing this way, and as it hits here, it's going to bounce up. And that gives us the illusion of this flat surface being a quarter pipe. If we move on to the next example over here, you can see, illustrate this a little further. So you can see here that this, again, our quarter pipe, and you can see an actual quarter pipe over here as we're doing it, the lighting is the same, okay? And if we take this line and we morph it, you can actually see that as we go up and down, the normals of the line are staying exactly where they are, right? So you can actually now visually see what's actually happening, all right? And if we unrotate these, like that, so they're all pointing up, you can actually see now that this quarter pipe is now acting like a flat surface. If we turn these off, turn the numbers off as well. See, it's like a flat surface. And if we rotate, now they're exactly the same. So you can see how normals affect how light interacts with the surface. So if we move on to our next example, we show our normals, you can see that we have our vertex normals, which are pointing perpendicular to each of their faces, okay? And if I change this from vertex normals, we have a cusp angle of 0. Even if we had a cusp angle of 60, they're pointing because this 90-degree angle is 60 is less than the 90-degree angle. But if we change this to point normals, you'll see what happens here with the shading is our box actually it looks like it's rounded. But it's not actually rounded, as we know. It's just that what's happening is these vertices are averaging in the direction that they're all pointing, right? This point normal is averaging the vertex normal direction. So again, if we go back to our vertices, you can see that this is pointing this way and this way. So this normal would be like that, right? And then if we go over here like this, right? This one would be like that. And then if we go like this, this one would be like that, right? And you combine them all together, and you get the average direction of all these normals, okay? And then as we've just learnt before, the reason why this looks rounded is because of the, the interpolation between the averaged and this one pointing directly up. So if we do this, it's kind of like going like this, then as like that, and then this one goes out, and then like that. So we're getting like that rounded shape. Okay, so that looks cool. So we can actually go one step further, right? So if I put this back to vertices, right? So we can do that. And if I grab this sphere, okay, I project our points onto the surface. You can actually see how we've moved the actual points. You can see here. So if I do this, you can see what's happening over here. Move the actual points. Let me do that and then that. There you go. However, we have not updated our normals. So if I look at our normals, you can see that they're exactly the same. We can update the normals if we go get the normal from the intersection point. So you can see now they're all averaged. But if we don't, you can see how it's a sphere, but it looks like it's a cube. Okay? We can even go one step further. If we take this, and instead of it being the vertex normals, we change it to our point normals, which is averaged, and we do the same thing, you can see now it looks like a sphere, but it's rounded cubes. Okay? And we can even go one step further as well, as if I take this and I bevel it, right? So you can see like that. And then I bevel it again here like this. Okay? And then if I project this onto here, because our normals have stayed, we haven't updated them, we get like this nice beveled kind of cube thing. Okay? So let's go and have a look at this in Maya. Okay, so we're in Maya, and I just have a standard cube that's been subdivided 20 times. Okay? And I have this sphere, but I've put the sphere on a layer, just a standard sphere. Put the sphere on a layer, and I'm templating it because I don't want to see it. Okay? So we can just hide it for now. What I want to do is I want to go to display, polygons, and I'm going to click this button over here and move this up over here. Okay? And if I select this object and I click on face normals, you can see that we have our face normals. Okay? Standard. And if I turn this off and I go vertex normals, you can see that we obviously have our vertex normals. Now, we don't have point normals, okay? And like we do, but we can't just like select it. We actually have to change the angle of these normals. So if I go to soft hard, again, you can see the soft hards. We're talking about if it's split or averaged. And if I change this to soft, you can actually see now we have the averaged surface. So it's exactly how it was in Houdini, right? And if I do the same thing and I go to hard, you can see now we have our split normals, or the hard edges. And if we go to soft hard and I click on the options, we have this cusp angle, right? What we spoke about. So I can select this, and we can go apply, we can change this, apply. It's all the same. When we go above 90, apply, and now it'll average and soften them. Okay, so I'm just going to put this back to 20, the default, hit apply. Okay, that's fine. And then I want to take our, yeah, we can just close this. I want to take our sphere. So I'm going to do this. I'll just edit and delete by type history. I want to take this cube and I want to select this sphere, and I want to go to deform, shrink wrap, okay, toward inner, reverse, short. So I want to click this, apply. You can see it expands it out, except we have a bit of an issue. Actually, I'm going to go display, polygon, bring this, turn the vertex normals off. I want to hide this. You can see that this is our object, except it's kind of like done what we want, but kind of not. Like if we do have a look at our vertex normals, you can see over here, it's adjusted them, but because the sphere wasn't like a perfect sphere where the ray hit it to do this, it kind of worked, it kind of didn't, right? But we didn't actually want to inherit the normals from the sphere, right? So all we then have to do is we just undo this. Okay, so we have this. I'm just gonna hide this again. I'm gonna select this, and what I now want to do is I want to go to Mesh Display, and I want to click Lock Normals. So what this essentially does, you can see they turned yellow, is whatever happens, there is no way we can change these normals. If I go to Soft, it's gonna kind of like do this weird thing. It's essentially locking them, but like, you know. So if I then select the cube and the sphere, and then we go back to project, and I do this again, boop, you can see now, let me turn off the vertex normals. You can see now that we've actually done what we did in Houdini, right? Our normals have stayed the same, and it's essentially a cube in the shape of a sphere, okay? So I'm gonna hide this. I'm gonna unhide our beveled, right? So we have our nice beveled cube. So it's the same thing. Select this. We have to go Mesh Display. We have to lock our normals. So bevel cube, sphere, and then just hit apply. And now we have our nice cube that looks like a sphere. Okay, so we're in Blender and we have a cube, just a standard cube that I've subdivided a few times. And we have an isosphere, just a generic sphere. Okay, and if we have a look at our cube, so let's like go into edit mode, and if we go up here, we can select this. You can see here we have we have our averaged point normals. We have our split normals, so you can actually see them differently. They're like separated, and then we have our face normals. Okay, so I'm just going to turn these off. And what I want to do, I'm going to go out of here, is I need to duplicate this. Okay, so if I Shift D and then right click, and I'm going to call this cube underscore project. Okay, excuse me. So I'm going to turn this off, and I want to add a modifier. So I'm going to go deform, shrink wrap, and I want to project this cube onto this isosphere. So we go target. We do that, so it projects it out. Except if we go into the edit mode, and we go into the, where is it? The wireframe, you can see how this is like all wobbly. So we want to change it from warp method to target normal. So it's actually going to use the normal to go out. Then what we want to do is I now need to project this detail onto it's kind of like its projected self, right? It's a different mesh, but it's essentially itself. So I want to then get a another modifier. I want to get a data transfer. So this cube project, we want to go, the source is the cube. And then we want to go to face corner data, custom normals, and I want to change it to topology. Okay, now you see this doesn't work when we're in edit mode. We have to come outside of here to this mode to see it work. Okay, and also our cube has to be on auto shade. I think if it's on smooth shade, it doesn't work. Yeah, it has to be on auto shade. Okay, so for us to see our normals, so if we want to go inside of this and actually see our normals, we need to apply this. So I'm just going to go apply and then apply. Oh, do we have to do it the other way around? I think we have to apply this. Yeah, and then apply the data transfer. So now if we go inside here, we can see this, and we can then go to our point normals. You can see here our point normals are pointing out. And then if we go and have a look at our vertex normals, you can see that these are split exactly how we want them to be split. Okay, so we can also now, because we're not changing the topology this time, we can actually go back out here and go add modifier, data transfer, cube, do our face corner data, custom normals, and topology. And if we bring up the cube and we right click and go shade smooth, if we now do this, you can see that it has inherited the smoothing from our cube. So I think if we go down to here and we do that, yep, there you go. You can see, so it's updated. If we change this to 110, you can see because the smoothing on that cube, so you can see there it's 110. If we just go back to under 90, even if it's like 85, it's fine. If we go 105 or 95, it just needs to be greater than this angle here, okay? So now we want to do the beveled version. So I'm just going to take this, I'm going to duplicate it, I'm going to hide the original, and I'm going to go cube, beveled, okay? And I'm going to select, so we go to edit mode, let's turn these off. You can probably all tell I'm very novice at this program. So we want to select sharp edges, and then let's hit Control B, okay. And then the segments, let's go 1, like that. Then I want to, again, just to add a bit of complexity, want to, let's hit Alt, oh. There you go, Shift Alt, okay. Select these. Okay, are they all selected? Cool. So now we want to Control B. There we go. Just like that. And we'll just add a couple onto here like that. Okay, cool. So we have this, and then I want to duplicate this. So let's go out here, Shift D, and I'm going to go beveled project. Okay, so I'm going to select this. I want to go to modifier, add modifier, deform, and I want to deform shrink wrap. And we want it to be the isosphere, and again we want to change this to normal, okay? Then I can just apply this, and then I want to take these normals from here. So if I turn our wireframe off, because it inherited the normals from the sphere, I want to project the normals from its original self. Okay, so we want to go add, edit, data transfer, source, cube beveled, and then we go to face corner data, custom normals, and we want to do topology. Okay, so now we can see that it has inherited the normals from its original self. But again, if we go inside of here, we can't actually have a look at them because it's like a post process. So we have to then apply it. So now we can go inside of it to see it. And if we turn off our wireframe is turned off. So I don't want wireframe. Where are you? Okay, I guess we have to. If we go out here, and can we turn on the... wireframe is off. Okay, I guess we keep it. All right, so we want to now, if we have a look at our point normals, it's really interesting here because they're actually like pointing out in the direction of the sphere. Like they're not like pointing in the direction of the points normal, so to speak. But if we have a look at our vertex normals, you can see that they're pointing in the correct direction. But again, if we have a look at it, they're not split. So it's like, it's the averaged vertex normal, which should be what the point normal is doing, but the point normals are pointing in the direction of the geometry. And this is, yeah, okay, so it's kind of a bit confusing. You can see why I'm doing this more in Houdini. It's just easier to illustrate this stuff. But there you go. So I've used Blender for all of, you know, a few hours at max. And you can see by just understanding these fundamentals, we can figure out how to do what we need to do. In this video, we're going to explore normal projection. We have a standard grid, and it's been subdivided 64 along the X and Y axes, or Z axes in this case. And I've given it some point normals, okay? And just pointing up. And I have this, our demo model from earlier, right? And I have our ray node that we looked at just before. So if I select our ray node, you can see that now we are projecting from our normals all the way up. And when it hits our model, we can actually see the imprint, much like those like toys where you can like stick your hand or your face in and it comes out on the other side, okay? But if we turn off our wireframe and look at our normals, just like with the quarter pipe example, we can just see that it's not actually doing anything to the surface. It still looks flat. It's actually just displacing the points. Now, what we can also do on this node is if we go point intersect normals, so if I click on this button, you can see that like what it's doing now is each one of these points, as it moves up, it hits the farthest point of our demo model. And then it goes, oh, what's the normal on that? And then it like points in that direction, right? So you can see, turn it off, turn it on, turn it off, turn it on, okay? Now, a cool thing is if we say, instead of let's displace the points and not use the normals, we can do it the other way. Let's use the normals, get the point normal, but don't displace the point. So if we bring this back down, you can now see that our object is imprinted on our flat surface, all right? Now, for all intents and purposes, this grid, the subdivision of the grid is essentially, if we think about this as our texture map, each one of these subdivisions is a pixel. So if we increase this to like 128, you can see we're getting more resolution. If we go 256, we're getting even more resolution. If we go 512, we're getting even more resolution. And you can just see now how detailed this is, right? And as we turn on our normals, I'm just going to make them very small, 0.05. And if we go into here, you can actually see how they're averaging over the surface where those points are, right? So you can see it's the same thing as what we've been discussing. It's just happening on a larger scale with many, many, many more points, okay? And if we have a look at this, we can start like rotating this. So we can just, I don't know, like 10 degrees here, you know, and the projection just kind of continues, right? See, as we're doing this, it's projecting. All right, let's go back to how it was. Okay, now you can see that we have like these ugly edges over here. And that's because, again, if we go into here and look at our normals, it's actually interpolating between this point and this point. And you can see that's why we kind of have these nasty edges. Okay, and that's why the higher resolution our texture, or our geometry in this case, the better the edges look. But we can actually go in and blur. So if I click on this blur node and I'm just blurring the normals, you can see that it's actually gotten a lot better. So if I put on our normals and then I turn this blur node off, you can see how sharp it is. Then as we blur it, and just see how better the interpolation is, okay? So you can actually see if we just take this and I just up the blur iterations, I mean, it just gets to a point where it's just gonna be like total mush because we're just blurring everything. You can just see how our normals are trying to just, every time we do a blur iteration, it's like kind of averaging the points around it and like reorienting themselves, okay? So that's kind of cool, okay? The next thing I want to talk about is if we now take the direction of our normal, which way it's pointing in world space, and we take that and we put it onto our color, right? So if I do this, you can now see that we're taking the whatever direction our normal is pointing, we're actually converting that direction into color. Now, if you're slightly confused, that's okay. We're going to explore this in a second. But before we go, just want you to just have a look and go and just think about, we talk about normal maps, textures, they're like that purpley color, right? And if we look at this, in this current state, this is like green, reds, and blues. All right, so we're kind of going into that direction to understand the normal maps that we put on our game models, okay? And you can see here that if I actually rotate this, so if I go like, 35, you can see how like the color is changed over here, right? And if we put this back to 0, okay, it's like going in weird directions. Okay, you can see how like the colors of the surface of the points change as we rotate our model. Okay, so why is that? So if we go to this box over here, okay, I just have a standard box, and above it I've created an axis. And what I want to do up here, I'm going to click on this, and I'm going to take what we just did on our grid, I'm going to do it onto this box, okay? So what we're essentially doing here is we're taking the direction that our normals are pointing. Let me just make these bigger again. 0.5, yep. So we're taking the direction that our normal is facing, and we're saying, okay, I'm going to apply that to myself, okay? Apply that color to myself, right? So if I take this, we can see that this face is pointing in the X direction, so it's blue. This face is pointing in the Z direction, so this is red. This is pointing in the Z direction, so it's blue, and this is pointing in the Y direction, so it's green, right? And that's just a universal 3D thing. X is red, Z is blue, and Y is green. Now, if we look on the back side over here, you can actually see that these are black, right? Now, why is that? Okay. What is that is in computer graphics, everything going forward is going from 0 and then up. So it's like 0, 1, 2, 3, 4, 5. And then everything going backwards is minus. So this is minus 1, 2, 3, 4, 5, right? Or whatever. Minus, million down there. And the problem is that our monitors can't actually display minus colors, right? So I could take these, and if I just do an absolute value, which is just saying if it's a negative, make it a positive, we can just see that our this is indeed on the x-axis, right? And this is indeed on the z-axis. This is indeed on the x-axis, and this is on the y-axis, okay? Let's turn that off for now. Now, if I take this cube and I actually rotate it, you can actually see as we do this, the faces actually start changing colors, right? And obviously, the reason is because they're now facing this face, instead of facing down the positive z-axis, it's in the positive x-axis, right? And we can do the same here if I do this. Now it's going to change color because now it's pointing in the y-axis, all right? So this is the vertex normals, right? As you can see here. But if I change it to point normal, so if I do this, you could see, because I'm running it over the points, and we're averaging this out just for explanation's sake here, I'm gonna put it back to vertex normals. But what we're actually doing here is, this is like a weird clown color, and hopefully you can deduce why, is that if this area, let's just turn this off, if this is red, this is blue, and this is green, and we add them all together, red, green, and blue equals white, right? So if we turn this back on, you can see here, because this point over here is pointing in the red direction, in the Y direction, and in the Z direction, if you average those colors together, you get white, okay? And down here, the reason why this is purple down here, let's just do another abs, is that because this is pointing in the X direction, it's pointing in the Z direction, so it's red and blue. And then down here, because this is black, even if we abs it on the point normals, it then goes like red and blue equals purple, right? And you can see here, it's also just adding the purple. And then over here, that's red. And then up here, you can see it's the green and the red makes the yellow, and it only goes yellow until a quarter of the way. Okay, now again, the reason why this is pure green is because these are like negative numbers, so it can't add it, and these are negative numbers as well. And you can see the turquoise because blue and green is this color over here. Okay, so that's what's happening. And again, if we rotate this, you can see that the colors will actually change. All right. Okay, so hopefully you understood that. So now if we go back to here, we turn off our point normals, you can see the reason why this has like all these different colors is because the normals of these, whoa, I'm actually going to turn this down to like, I don't know, 64. Yeah, there we go. Let's do that. So the normals of these are pointing in the different directions and going, okay, well, let's just go like something over here. Like this one over here, it's like it's pointing mostly in the Y. So if we go blue, so blue is that way, and then red is that way, and then green is up like that. So this is pointing mostly in the green, like, and then mostly in the red, and maybe a little bit in the blue. There you go. So you can see it's doing that. Okay. So that's why we're getting these colors when we convert it. Okay. So I'm going to put this back to 256 or 512 because what I want to do next is say, okay, now that we're storing the normal direction, the point normal direction as a color, let's just like reset our normals. Like who cares? So now if we reset our normals, we actually have no lighting information on here anymore. So I can actually turn on, if I go over here, I can turn on a light. There we go, we have a light. Let's go over here. Normal transfer. So we can, we want to go into here. We want to take this, pop this over here. So if we do this, okay, see we have our normal. See that works nice. Okay. And then if we go into here and we say, let's just put our color on, that's fine. And then if we reset our normals, you can see that we have all our color on our points. So like our normal direction is on our points, but we've just removed our normals. And you can see that they're all pointing up. Oh my goodness. 0.05. Okay. Cool. See, they're all pointing up. Great. We get it. Nice. Move along. So what we can now do is we can go into here. Don't worry about this code. It's fine. We can actually now turn off this color. We won't have to worry about it. But what we can actually do is we can say, okay, let's take our color data and which is a direction, and convert that back to normal, right? So if we do that and we kind of do this, you can see now we're able to fade in and fade out our normals. So if I do this, you can see it's nothing, right? And then as we do this, you can see how our normals are adjusting. Let me turn off that. There we go. That's probably better. So if we do this, you can see how our normals are shifting. So we're taking that color data and we're shifting it into, we're putting it in our normals, right? So then if I turn off this and I turn this up again, that's the color that we have. And if I blend that out, you can see that's green, and green is pointing up. So that's why our normals are just pointing up. And then as we blend, this is just blending the color in, but then as we blend our normals in, you can see that it's changing based on that. Okay, so you can do that, and then we can do that. Okay, so hopefully you can understand what's happening here when we talk about world space normals, right? The reason why they say world space is because the direction of the points are pointing in world space. So what we're going to do in the next video is take this concept of projection, instead of projecting it onto normals, we're going to project it onto a texture. Okay, in the previous video we explored projection and how we can project off of our plane onto a high poly object and return the normals in order to transfer that detail from the high poly mesh onto a flat surface, right? To fake the illusion of detail. So that's worked really well. We've got these nice normals onto our plane and it lights really well. However, that doesn't really solve our problem, because if we look at our plane, it's actually 261,000 primitives. For illustrative purposes, this is great because, you know, each of these like little grids or these subdivisions represents a pixel. So what do we want to do, or how do we represent this detail on a lower polygon mesh? And that's when texture baking comes in. And essentially what texture baking is, it's like when you create like a clay pot. You get your clay, it's all wet, you can manipulate it and change it into whatever shape you want. And then once you're happy with that, you can put it in the kiln. And then once that's done and you take it out of the kiln, it's set. You can't change its shape. You can't update it or do anything to it. That's just what it is, unless you obviously break it. Okay. So that's the idea of baking a texture. So what that means for us is we want to then take this normal data, this vertex normal data, this point normal data that we can change and update, and then save that to a texture so that we can't change it, okay? And that has many benefits. One of them being, instead of having a 261,000 polygon plane or model, we can have a 2 polygon model. So again, if we have a look at our grid here, this is 2 polygons or 2 faces, right? And above it, we're going to have our model, okay? This is our normal model. Don't mind the light. Okay, we can just turn that off for now. Okay. So on this grid, I've given it UVs. We can just have a look here. So we got UVs. Okay, like that. Let me actually just like rotate this as well. Would you rotate it on this axis? Yeah, let's do that. So we'll rotate it 90. Okay, and then I've given it normals. Right, so we just have point normals. It's fine. And then I just divided it because we just want to have it as triangles instead of quads. And then I gave it a basic material. Now, the material doesn't matter in this instance. It doesn't matter how I'm doing it. Just whatever program you're using, you can just put a material on it. But for those using Houdini, it's just a standard principal shader. I've already put a texture in there that's not doing anything. We're going to bake to it. And under bump and normal, we've just, you know, enabled normals. It's fine. Put a texture in there. And under surface, the albedo is 0.5 and our roughness is 0.5. So now if I go back to the object, I want to go to our bake, our out. And this is where in Houdini we do texture baking. All this essentially is doing is we're going to give it a texture. Essentially think of that as our subdivided grid. And then as we, for each one of the pixels on our texture, we're going to fire a ray, like the ray tool that we used before when we were projecting onto this object. We're going to fire a ray, and then when it hits something, it's going to return the normal, and then save that to a texture. Okay. So if we have a look at this here, this is the ground over here. So we're looking at it from the right-hand view. So this is the ground over here. And essentially what I want to do, so this is our ground over here, is when we fire a ray, we need to know how far, see this like ray bias, like how far do we fire the ray. So what I'm going to do is just for a first test, I want to fire the ray up to over here, so a distance of 5. Okay, we're going to put it over here. Okay, and we'll see what happens. So every single one of these rays will just, for every single pixel, will just go up to 5. Okay, so I'm going to put this to 5, and then I'm going to hit render. Okay, so a few things have happened. First up, our model has, our texture has been created. So this is the texture that came out. One thing you'll notice is that it is not the greens. So if we go back to our object, I'll turn these off for now. I'll go back to this, and we want to go here. I'll turn this down and show color. Okay, let's turn this off. So you can see that it's not the greens, it's a blue color, okay? So as we kind of mentioned before when we were talking about this, is that these normals are in world space, right? So this is pointing down the z-axis, so it's blue. These are mostly pointing down the x-axis, so you can see the red, so it's kind of red and a bit upward, so it's red and green equals yellow. And these are mostly pointing up the green axis, so that's what's happening here. But what's happening here is there is a concept called tangent space, which we'll go through in the next video. But also what I want to look at, what's even more obvious, is how like garbled up this image is, right? Okay, so we're going to go back to this, okay? And let's just have a look at what's happening. So firstly, you can see that we have our circles, our screw circles down here. And when we look at them, there's actually no like data there, right? It's almost like we're seeing inside the model, but also like outside the model and like inverted, right? So if we continue to explore like, okay, this here, this looks okay. So what's actually happened here? Or like, should I say this over here, right? Actually, in fact, like none of it looks okay, right? But what's actually happening in, let's just say, this area here, you see, we can only see like a little bit of this area down here. And what's happening is the ray for these pixels is like firing up, okay? Let's just say, what's an area? Like, okay, let's go in here. Like, this is fine because we can talk about like these two areas. So over here, the ray is like firing up, right? And it's hitting like this surface over here, okay? So it hits it, it goes, okay, cool. And then it continues going through all the way to that 5, up to the 5 meter mark, right? And if we actually go inside here and look at this model, we keep going up. It's actually not hitting anything else inside here, right? So what this ray is doing is it's going up, it's hitting this. It's like, okay, I've hit a surface, but I need to go up to my 5 meter mark. So it's all going up. And then it hits 5 meters, but it doesn't hit another piece of geometry. So it goes, okay. I go up here, I hit this, cool. I keep going. I hit nothing else because it's inside. So it goes, okay, I've hit over here. What direction is this facing? It's facing that. Okay, now I'm going to take that and I'm going to put it on the texture and I'm going to encode it into the texture. I'm going to save those values, right? So I'm going to save that pixel value being red this much, green this much, and blue this much, right? To give a direction, as we know, red, green, and blue. Except because we have like, this is like in a negative value, it's kind of coming back, you know, like if we look at it like this from the back, that's fine, okay? But then if you have a look over here, what's happening is this ray is going up, it's hitting here, right? Like this area over here, and then it keeps going through, right? Up to here, and then it hits this surface over here is the final surface that it's hit or wherever, and it goes, okay, cool, and then it returns that. So what we're essentially getting here is this cross-section of our model. Like some areas it's hitting down here, some areas it's hitting like on the side here. Some areas of this brick, like if we look at this brick over here, this area is perfectly fine because it's hitting this pointing upwards. So when we look at it, it doesn't look like it's an error, right? But this one kind of looks like an error, and so does this. So essentially what we're getting is wherever that 5 meter mark is, we're getting anything that the ray, we're getting the last object or the last surface that every ray hit on its way there, okay? And then returning that and doing that and writing that to the texture. So essentially what we need to do is, if we go back to the out, is I'm just gonna put 10 in here because we know that it's gonna clear this whole object. And then let's do another bake. Okay. So let's have a look here. This looks a lot better, right? So if we have a look like this, this looks perfect, right? We've got the top here, it's returning the normal. Like even if we go to the top, oh, that's not the top, that's the top. Even if we go to the top and we remove this, we can actually see that it's a carbon copy of it. Look at that. Isn't that cool? Yeah. So if we turn on our lights, like this, we can take this light here. We can like move it around. So we've got nice normals, okay? So if we have a look at our texture now, you can see that we have this really nice texture, right? This tangent space normal texture. If we go out, yep, we got our tangent space normal. So like, what is this? And why is it different to the green one that we had? Go back to it over here. Why is it different to this green one? And why should we care? Okay. And really, this is what games use more often than not in order to put all of the detail on their model in an efficient way that allows artists to, you know, create something that's consistent with the least amount of calculations. Okay, so in this video, we want to discuss tangent space normals and kind of go into what exactly are they. But first, let's like define the problem. So if we have a look at the textures or the normal maps that we use during game development, they've got like this bluey, purpley color, right? And we need to create, and the reason why they are is because we need to have something that's consistent between bespoke model textures, like when you bake a model texture, and also when you just have like a standard tiling texture that you can tile over a model, you know, a generic tiling texture. Okay, so that's why they have like these purple colors, because there's like a standard between the two. Now, where did the standard come from? Okay, so if we go up to here, so I have this box, and we'll go to here. Okay, so what we'll do is I'll just morph this down. So we have our box. Let me just turn this off. And our box has UVs, right? Let me just turn this down as well. There we go. So our box has UVs, which is the standard box. And again, instead of using texture maps in this, I'm going to use our vertex colors because I think in this instance, it's a good way to kind of explain what's going on here. So when we talk about tangents, right, we're talking about it from a texture map point of view, okay? If we look at our texture map over here, if you see down here, we have this U and this V. And what the U is this is the tangent or the U direction. And if we go up, this is the V direction, right? And if we come towards us, that's the normal, right? And then as we've just said, that's the U, and then that's the V, right? And as we know just from standard school maths or whatever, like when you have a look at a 2D graph, green is on the Y, and then x-axis is red, okay? So from here, okay, if I actually turn on this, where we can see if we go to our blend shape. So let's just blend this out, okay? So what I'm actually doing here is I've arranged our points to reflect our texture map. So if I have a look at this, you can see our points here are in world space, but they're the same as what they are in the texture UV space, right? You can even see that this is the y-axis. You can see down here, let me just do this, okay? You can see like this is the y-axis, the x-axis is going across, and the z-axis, right? So it's exactly the same as how it looks on a texture map, all right? So from here, what we have done with this polyframe node is we have given it the tangent u and the tangent v. So if I look at them, you can actually see now, so if we go up here, we don't have the tangents. And if we go here, we do have our tangents, okay? And all 3D programs like give models tangents. I'm just using Houdini here to kind of show them to you, right? And these are the tangents based off of the texture map, or sorry, the UV space, okay? So what's really cool about this, right, is if I go down here, I'll just place some arrows on here. So I'll just turn these off so you can just see it a little bit better. So we've got these arrows on here. And the cool thing about this, and the reason why we use it, is if I rotate one of these UV shells, so I'll just rotate this island, you can actually see that our tangents are always pointing up, okay? And the reason why that's useful is because no matter which orientation we put our UV islands, the up direction of our texture, of our tangents, is always going up, okay? It's always pointing up, okay? Now that might be a little bit confusing because there is no visual data, but we're gonna expand upon that as we go forward, okay? So if so we've given it our U and V texture tangents, right? And then what I'm gonna do here is I have these models that I've just placed here, and I'm going to just project them as we've done previously onto our box, okay? So let's just get a little bit higher resolution. So now we have projected it and we have our normals. So we know exactly what's going on here. We don't have to go into it in any more detail. But what I'm actually interested in here is if we display normals, right? So now what I've done is I've taken those normals, the normal direction, and I've placed it onto our the colors. So essentially what we're doing now, if you can just bear with me for a second, and is we have now like projected this or baked it onto a texture. Okay, our texture being our 3D model. Okay, in this instance, but if you could see like our UV, right? And the reason why I'm doing this is because we can kind of manipulate this data, and I can actually show you what's kind of happening under the hood before the texture is actually like saved to disk, okay? So we have this like this, it's all projected. And then what we do next is we extract the blue channel or the normal, right? So if we have a look at this, all right, this is the red channel, which is pointing to the right, as we know, right? The green channel, which is pointing up, as we know here, and then the blue, which is pointing forward. So that's what's happening over here, okay? So if we extract the blue, so if the face or the normal is pointing directly towards us, it's 1. And if it's pointing on either side, it's 0. And if it's pointing backwards, it's -1, okay? And we can also do the same there if we then, I'll just isolate, we don't need to isolate. So we go like the U, right? So this is our tangent U. So you can see here the U, it's pointing to the right. So if any tangent is pointing fully to the right, it's white. If it's pointing fully to the left, if it's pointing fully to the right, it's 1. If it's pointing fully to the left, it's -1, okay? And then if we have a look at the V, again, if it's pointing fully down, it's 1. If it's pointing fully up, it's -1, based off of our texture coordinates, okay? Now, if we combine them together now, so if we have our U and our V, okay, if we combine them together, we get this texture that, or these colors that kind of look familiar if you work in, 3D art. These are our texture coordinates, okay? But the problem with this is that this is going from 1 to -1. Now, we can't encode this onto a texture because the textures that we use go from, they don't go below 0. We can't have negative values. So what we then do is let's just say for the U channel, what we do here is we take it, we add 1. So we now, instead of going from -1 to 1, we're going from 0 to 2. And then we multiply it by 0.5. So now we're going from 0 to 1. So if anything is pointing 100% this way, we're a value of 1. And if we're pointing 100% this way, we're a value of 0, right? So you can even see here on the sphere that we've got like this perfect gradation from like 1 to 0, okay? And that's the same if we do that on the V, right? Anything pointing down is 1, anything pointing up is 0. So if we take those now and we add them together, we combine them, you can see now that we get like this nice kind of gradation where if it is 0.5, it's pointing forward, and if it's 1, it's pointing in its respective direction, and 0 the opposite, okay? So then what we can do is we combine them together, and now you see that we're actually getting this normal map color, okay? This is the same, it's just Houdini's viewport has like some colored tone mapper stuff on it, right? But it is the same color, right? Now, what we've actually done when we calculated the U and calculated the V is we've actually done a dot product between this normal and the tangent U or the tangent V. And what that means is that based on our texture map, right, because the tangent is, because this is all set out default, the tangent is to the right, right? So if I turn these on, I need to make them smaller. So let me just make them smaller. Okay, so you can see now that they're facing in their respective directions, right? So that's fine. But if I now go up here and I rotate an island, so I've just picked this island over here. If I rotate it, so you can see what's happening is as I'm rotating the island, because the tangents, 45, because the tangents are updating, right? Then what we're doing here is we're doing a dot product. So we're saying, okay, if you and I are pointing in the same direction, you're 1. If you're pointing in the opposite direction, you're -1. Okay, and if if you're pointing to the side, you're 0. Okay, so we're doing a dot product between our normal, or sorry, this normal here, over here. There we go. Between these display normals over here and our tangents and bitangents. Okay, and by doing that, we're able to get, let me just turn these off. We're able to get the direction of the tangent and the bitangent. Okay, so I'm just going to go up here and I'm going to continue to rotate this, and you can see how it's red always pointing to the right hand side, but actually on the actual texture it's the same, right? So we're not actually rotating the model, we're rotating the UVs, and we're using the normals, tangents, and bitangents to actually calculate where light is coming from, because it always needs to be coming from the right-hand side on our texture map. Because if we go inside here, you can see that if I look at the red, you can see the light is coming in from the right-hand side and it's darker on the left. If I have a look at the green, it's coming in from the bottom and it's dark on the top. And if I have a look at the blue, you can see it's like where it's pointing away from the screen or your phone or whatever you're watching this, it's darker. And if it's pointing directly at us, it's brighter. And that's the same with this. If we go to the red, you can see here, it's white over here, black over here. The green, it's white at the bottom over here, and it's black at the top. See over here, and the blue, right? It's the same. So we need that consistency, all right? So if we then just go back down to here, you can see that if we rotate our islands, you can just see how, and this means that when we're actually laying out our UVs to bake normal maps and stuff, it doesn't matter what rotation or orientation it is, because the normal map, like when you're doing the baking, it's going to do all that calculations to say, okay, we're rotated this way based on the tangents and the bitangent, so we're going to put these colors over here. And then when we decode it, it knows how to decode it and where everything is, okay? Now you may ask, well, why don't we just take this, right? Instead of doing all of this stuff, why don't we just take this and then just make it so that it's, 0 to 1 instead of -1 to 1? Well, the problem that we have, if we have a look at it here, is that if we switch it, the green channel over here is actually pointing up, because again, we're in world space, right? So if I do this, we're in world space, you see green is pointing up. But green on a tangent space normal map needs to be pointing down, okay? So then if we again have a look at this, is that red is pointing to the right, positive red, and then negative red is pointing to the right. So that's okay, right? And then obviously, if we go to the blue is pointing towards us. So this is in world space, right? And that's actually incorrect. So if we now go up here and rotate the island, this doesn't actually update, because we're encoding our quote unquote, we're doing the math to make it look like a tangent space normal, but it's not actually getting its data from the texture coordinates, right? You can even see that this is like wrong here. You see the green is up here, right? Okay, so we'll take this, and then what I'm going to do is I'm going to then just collapse it back into a box. Okay, so now we've baked our texture. It's in here. Let me just actually put this back to 0. Boop. Okay, so we've baked our texture. We've put it back onto a box. Okay, so now what we need to do is we need to take our tangent space normals, which is these, and we've put it on our model in our game, and we now need to convert it from tangent space to world space, okay? So I'm just gonna pop this over here just so that we can see that this is our axes, right? Our world axes, right? So we need to do the reverse as what we did before. So I'm going to remove our, the normal, like the blue channel, right? And then I want to remap our red and green channels to -1 to 1, right? And we do that by just minusing 0.5 and multiplying it by 2, okay? So now we have our colors over here between -1 and 1, okay? Then the next thing then we want to do is convert it from the tangent space to our world space. So how we do that, if you have a look at this little bit of code here, it's actually quite simple, is we're actually taking, if we go up to here, this is like our new quote unquote texture map, okay, that we've taken the data and we've put it back into world space, okay? So what we then want to do over here is we want to say, okay, let's get our tangent U and tangent V from the texture map, and then let's also get the normal or the blue channel from our texture map, and let's store that. Okay, so we've just stored that. Then what I want to do is from our actual model, I want to get our tangents. Oops, let me just turn this on. I want to get our tangents and our bitangents from our 3D model, right? And then from that, I want to then go, okay, so our normal world space is our textures red channel, so the U, multiplied by our model tangent. So our texture tangent multiplied by our model tangent. So that would be the red. So if we turn this on, so that would be the red, okay? Then, so that goes into the normal red channel. Then in the green channel, we want to get our textures bitangent, or the V, right? And that would be in the green channel. And I want to multiply that by our model's bitangent, okay? And that is this one over here. And then finally, what I want to do for our blue channel is I want to get our textures normal, and I want to multiply that by the blue channel or our model's normal, right? To get the actual direction of that, okay? And that's how we arrive back from a tangent space, so the space from that our texture map has, to our world space, right? And the cool thing about this is if I then take this and I rotate it, you can actually see that our texture map combined with our model's normals and our model's tangents and bitangents, we're actually getting the correct world space coordinates of this, right? And as we rotate, it's updating perfectly fine, right? So now if we take this and we apply it, boop, you can see now that we have really nice normals that we can encode to a texture and then, you know, read back and rotate, and everything is hunky-dory, okay? So what we've done here for the most part, well, not for the most part, but what we've done here is we've solved the bespoke. So this is essentially a normal map that we have baked for this model. Okay, it's very simple. There's nothing quote unquote bespoke about it in the sense of any particular features. We've just projected some data onto this model and saved it out as a quote unquote texture. So we've solved this bit here, okay? But what about if you now want to just take a tiling texture and stick it and add it on top of this, okay? Well, if we go up here, and where is it? It's over here. So we've done our ray. We've done all this stuff over here. We have this. So now what I can actually do is inside of here, what I'm doing, okay, doesn't matter how I'm doing this, right, is I'm actually reading this texture right over here, and then I'm adding it, very basically, I'm just adding it onto our normal map. So then if I crank this up, you can actually see here that we are still using the same thing where we're getting our tangents and bitangents from our textures. Okay, and we can how much do we want to tile this, right? Because again, if we have a look, we're tiling it in the texture space, right? Doesn't matter how much we do this, that's fine, because then we're taking this information here, and then we're going down to here, and we're then saying, okay, let's remove the blue channel, let's remap that to -1 to 1. Then we want to combine it together and then do the maths to convert it into world space, right? So now we have this. And again, it's the same, that if we rotate these, it all updates nicely, okay? Like that. So now if we just pop it into here, we just apply it. Now we have our normal map. So we can turn on our lights, and everything is great. And if we come out of here with our lights, we can move this around. And we're combining quote unquote bespoke normal map and just a tiling normal map onto here. Okay, so you can go inside here, go back to this, you can tile it 8 times, doesn't really matter. Okay, and obviously like these jaggies are just because of our quote unquote pixels or our grid. We just don't have that much. So if I go up to here, all the way up to here, and I change this to 1.5, so we're just getting more quote unquote resolution. There we go. That looks a little bit better. Okay, so we can even then now, because we know how this all works, we can kind of go full circle, or I can take this and then I can project it onto a sphere like we did way back when, and it just works and looks nice, right? And we have our tangent space normals, right? So I hope that was useful. We can also go up here and bring down our strength. So we can go like 0.25 because it's too strong, or 0.5. There we go. That's a little bit better. Okay. So you can even see like it's cutting off here, but that doesn't really matter because we're, it's tiling and we're doing all the correct calculations. Okay. So I hope that gave you a better understanding of the concept of tangent space normals and how useful they are. Because we can use them for bespoke textures and we can use them for tiling textures and all kinds of, normal map textures. And it also allows us to get a standard, it standardizes it throughout the industry, right? So you can just have programs like Substance or Blender or Houdini or whatever, make these textures as long as there's a standard, and then we can just decode them and they work great. All right. So the next thing we want to do is discuss normal map baking, texture warping, and texture stretching. Okay, so let's have a look at normal projection from the point of low poly model and how the normals affect how the projection works. So I have this high poly set of screws, okay, just sitting on the top. They're their own model, okay? And underneath it, I have this low polygon grid. It's only got 2 triangles, right? And the normals are pointing straight up perpendicular to the surface, okay? And we just have a standard, so we have a look, we just have a standard, UV map, or should I say, UVs on it, okay? So I'm just gonna do a bake, hit render. Okay, so this is as expected. So if we go to our object, can select our light, we can like move this around, right? And this is perfect, right? It's a top-down, perfect, normal projection, right? Our screws look great. Everything is wonderful. Okay. So if I go into the next one over here, you can see that I've actually bent or, rotated these vertex normals, or should I say these point normals, away from, they're not perpendicular from its face anymore. And just like in the first video, we actually have like this rounded edge, right? Or this rounded kind of lighting. We've distorted the lighting to create like this rounded effect over here, all right? So I'm gonna do a bake of this onto the same screws, and hopefully you can guess what's gonna happen. So let's just do a bake quickly. Okay, so our bake is done. And something's interesting has happened, okay? If we just move this light over here, you can see that our normal projection is skewed, right? Now, hopefully you can kind of deduce what's actually happened here, okay? But you can see over here is that this is like almost perfect, not totally, but almost. And this is a little worse. And this is significantly worse. And this is like the worst, okay? So hopefully you can deduce what's actually happened here. And if we have a look, the normals over here are pointing perfectly up. So as they go up, it hits the screw and then it returns the normal. But if we go over here, what's actually happening is as this normal here projects out, because it's pointing this way or, you know, near this way, let's say it's over here, it's going out and it's hitting that over there. And whatever that point is, it's returning that, okay? And you can see, because as we go further along, as we know from previously, this is going out and then this is going out and like this and this and this. And as it kind of goes up, it's starting to go up like this, right? And you kind of have that kind of curve all along here, right? That's why if we lay this over, you can kind of see that it starts like breaking, you know, a little bit of distortion going on in here. You can see there. And then it starts breaking over here, and this is like terrible, right? You can see that. So how do we like fix something like this? Well, in our third example over here, we've got exactly the same thing, except I'm putting like a support edge over here. And what that means is, you know, all of these are pointing up, and then this one over here, you can see, you know, is pointing this way, right? So what actually happens when we bake this, right? So I'm just going to hide these, go to our out, go down to here and hit render. Okay, cool. So now you can see that like these are perfect now. And this is the same. It's like totally screwed, but not as much, right? Because if you see, the closer that we get to these perpendicular normals, the better that the better this is. So if we go back here and we switch between these two, you can just see how like terrible this is compared to this one over here, where like this is nice. So it's actually interesting over here is that this over here in itself has that kind of curve going down. So like this is pointing up, this is nice, right? And then as we keep going, like this is great. And then this is like a little bit like that. And then this is more like that. And then this is more like that. And then this is like totally like that, right? So we got like this curve coming down from here like that, okay? So this is one of those offenders when you're looking at your models and when they're being baked and you're seeing that details are skewed and warped and facing different ways. This is the reason why, right? And in the next video, when we start talking about when we go into baking the high poly and the low poly together and setting up the normals and our UV islands, we'll go into how to solve this problem.